All right, good morning, everybody. This is Captain Office Hours on February 15th. Wow, February. As always, this is posted to YouTube after, so don't say anything you wouldn't want. And I'll let you take it away from here. Wei, you were going to talk about the quota proposal that you have. Do you need share screen access, or do you want to just talk?
If I haven't prepared for the share screen. Let me check where my screen. So I can share the screen, yeah.
Okay, I have made you a co-host.
Sorry, I lost. Okay, sorry. Yeah. Okay. Let me check. Share screen. Okay. No. Computer very slow.
Is that working out for you? Do you want me to share my screen and just open up the pull request, or?
Yeah, I can. Yeah.
Okay, cool. You were frozen on my end, so I just wanted to check.
Yeah, is it okay now?
Yes, I can see it.
Looks good to me.
Okay. Yeah, okay. So let's just go back to the original document. Chris has reviewed it and get some feedback. So I update it with all the. Sorry.
Yeah, I just have some concern with that tenant map. So I see your reply.
Okay. Tenant map. I didn't reply anything from you.
You didn't reply? Okay. Anyway, so I was missing that 2 hours periodic update. So in the first place. So
okay.
Anyway, so I probably just didn't read through it carefully.
Okay. Here. So the document here. So if we can see clearly, so the motivation is that we want to add in the quota. So and unfortunately, each quota deployment or implementation are not very common, and for each different cluster, people are having different way to track quota and use the mechanism to validate. So it's not allowed us to share it. So better we just give a option to plug in the proper place where I think it is the best fit for all the entire thinker. So what the place I choose is that in the pod thinker that we can do this before we create a P pod in the supercluster at very last stage. Before do a create, we check the validation and see if there is enough quota or whatever the plugin the user wants. We just validate it, and then the decision were made based on the validation, and it's either create the pod or reject it. Reject the way is that we do not allow this B pod to be requeued to reconcile. Based on the current model, we probably do 3 times reconcile, but this is, I think, is not need to be reconciled because it's not valid. So we immediately send to the queue for the patroller to do it in a next period. So this is the things we can do that, or you want to do reconcile 3 times, it's all fine. We just return the error message, and that can be retried. So the only things that this is simple for this entire logic. So another big thing that we really don't want to break mechanism as we discussed last time. So in this case, I'm thinking that we probably can have a lock that is unable to lock per tenant when we do the validation, because normally when we do the validation, we don't want to have the same virtual cluster have the same tenant do the creation the same time, because this way we very unlikely can get the accurate quota and do the validation. So we want to introduce another quota related to lock. We call it per tenant lock. So this is the logic that I want to introduce, that the lock cannot get tenant. Then we get tenant, and there is a tenant lock here. So this is the basically data structure that we want to lock it per tenant, and we have a tenant map, and this tenant map will be periodically updated, so that we can have this this lock in place for each tenant. And if multiple tenants is working on the same different quota validation, they can be done in parallel, but just make sure that each tenant for each virtual cluster, they only had one thread working while do the validation. And this will be also true before this one, because I did the unlock deferred. So this won't all be included in the last instruction that need to be locked. So when we introduce that, this p-pod creation will be auto locked when the validation. Then I will also introduce a flag so that this one won't be accessed if there is flag disable this entire logic. So this entire logic plugin won't be able to impact the other things if they don't want the quota validation happening. So this is basically several things. The plugin itself is quite similar to the one you introduced in the virtual cluster plugin. That's the same data structure almost. So you can, if you look at this one, is very similar. So basically, this is the initialization part for each plugin that we did. This is very similar to what you did. Yeah. So this is all the ideas behind it. So I'm not sure any. There is a location where we want to discuss if this is a good place. Second is the lock. Third is the plugin itself, if you have any concern about that.
Yeah, so tenant map. So what I'm just afraid if a new tenant is joined, so how can that new tenant add into the map immediately? It seems like you have to do a patroller kind of thing.
The tenant, I think, let me check the code myself. I think it's pretty straightforward to add this tenant, because let me check.
Yeah, I know you can do that just in the tenant controller.
Yeah.
At a plugin point. So that's why I'm asking, do you need to add a plugin point in that place?
No, I don't need. I think the tenant map is retrieved dynamically. If there are no, I just create one. So I just checked that. So okay, logic is that when the tenant there is a in the reconcile here comes in. So I just do a read lock and see my map has any instance of this new tenant, which is coming from this reconcile. And this reconcile, if there does not have this tenant, I just added one in. If there is already existing, then that's it. If no one there, I will add one more in. So the tenant may be different from yours. Our tenant means is a class name, which this is we consider is a identification of tenant.
Yeah. So the problem is if the tenant is removed, to remove the entry from the map.
Yes. So the tenant will be removed periodically. So it's not very harm to have this tenant stay there for a little bit longer, because if the tenant will remove, there are no requests coming in. So the map can be stay there with this tenant entrance still stay there. However, I have a periodically kind of 2 hours or 1 hour, whatever we think is appropriate, can remove this tenant from the map. At this time, we do a write lock and check all the tenants and then make sure that this one is no more there. I'm not using your mechanism that you use a timestamp, then see how long they have the last request. But this, I think the mechanism I currently use is just simple. That goes through all the tenants, and the tenant is no more there. Then
So I understand. So my point is from the plugin perspective, this may not be a good design because you have a lot of hidden, because the interface is not clear. So I don't know the life cycle. So you have your implementation, that's okay. But if anybody else who want to come with it, they probably don't know how to maintain the tenant map, right? They probably don't have the thought that you have to how to add it and how to remove it. So that's the reason I'm asking. So that's the reason I'm saying maybe hooking to existing lifecycle. So basically binding the tenant map with the exactly tenant object lifecycle seems a better idea, in my opinion.
can you repeat it?
So binding the tenant map,
Yeah.
each entry in the tenant map with the lifecycle of the tenant object.
Okay. Okay.
So basically you probably need a extension point in the tenant controller, but because you want to make sure the lifecycle are consistent between the map and the actual tenant object. So that I think is going to be more clear, because otherwise, unless you, I mean, so everyone want to extend using this plugin, they have to make sure they implement exactly the way that you implement for the tenant map, right?
No, this plugin, I think tenant map our give as a component that they release it. It's not my implementation. This tenant map is part of this plugin. So all these things will be part of it. Yeah,
No. I mean, you have a tenant map, right? Somewhere. I think should be here. Tenant.
Yeah.
Tenant map. So tenant map is go down. There is a tenant map, right? You have this.
Yeah.
You have this all tenants. So I think this all tenants is going to be part of the plugin, right?
Yeah.
So if you just give me this plan, this plugin, so I have no idea how to maintain this all tenants.
Okay, I can think of that to.
Yeah, so just think about it. So we release a plugin, right? And this is part of a plugin. The assumption is that you guys have, I mean, implementation. Let's say Alibaba has Alibaba's implementation. Then there's one guy there is a plugin see these all tenants. So I have no idea how to. I mean, I can implement it anyway, but from the plugin perspective, is it clear or not? I'm not exactly very sure.
Okay. Also, another option is that
because for so in my opinion, if you have a plugin, you have any fields, you'd better in the plugin you have very clear description how to maintain the, I mean, how to manipulate the, how to control, how to in this case, I don't think a comment is good enough. So
okay. Yeah, let me think about it then. Another option is that I get rid of all this the locking tenant map stuff. Let this is decided by the user. So all I need to do is just put a simple plugin here, inject the plugin there, and whatever you implement tenant map, do the lock or not, no lock.
No. The lock has to be there for sure. The whole problem
no,
is
you can just.
lock?
So the thing that all this code was hidden for a plugin, and this code, I will put this code also into here and get a return whatever I think is perfect. So the lock will be hide inside the plugin for the customer who designed this plugin itself. But the plugin itself is just a very simple plugin that we inject one piece of code here. We call it a plugin, and they no.
I don't think I mean, in my opinion, the lock has to be there if you have a plugin. So
Okay.
otherwise, it's so easy to get it wrong. So
Okay.
There technically is a way that we can get around the lock, though. I mean, if you enforce that the checks are happening like the quota checks are like quota checks happen in admission lifecycle, you could do it without the lock. I'm pretty sure, right? Because you could be checking the objects, the underlying object. In our world, that's our virtual cluster quota object, and continuously updating it and failing on conflicts in essence, or not failing, but retrying on conflicts and failing out if there's not capacity from that. Which then you don't actually have to have a lock. It's just everything is just distributed. Maybe I'm wrong. Might be.
you still need to have a lock, in my opinion. So
Okay. Yeah, I'm just thinking from like the Kubernetes API server side of things, when it's spread across, 3, 4, 5 instances, it doesn't have a lock.
No.
It does.
When they do quota check, it has to have lock.
No, it distributes it by using in essence retries against updating the status on the quote object or the resource quote object. So we run into an issue. We run into an issue all the time where the API server will have
No, Chris. The reading is okay, but we need the atomic kind of operation. Read the quota, then do the creation. So these two operations need to be in together. This is the problem that. So this is why these two lines need to be locked. That basically is not the checking the validation of the quota, how much we have. But while we have the checking, we know it is true, then we will need create immediately, no delay, within the same lock. So there are two operations happening together, need to be together. This is why we need a lock. It's not just because we read this validation or read this quota or not. Read is okay. We can always get up-to-date read without lock, but after read, the fresh information have to be used. Then the next guy can use it.
I think as long as you have two threads touching one map, you need a lock. So otherwise, so anyway, so
true, yeah.
So I would say API server doesn't need a lock if they don't have in-memory data structure. So if we just if they just update storage and using the storage update conflict to resolve lock, I would say they have a lot of problem on this is something inherent problem.
It does.
You got failure later.
It does. You basically get tons of conflicts. You get 429s all over. Like when you really use
the resource that's in my opinion is such a poor design. But anyway, scheduler definitely doesn't do that. I'm pretty sure scheduler won't do that. Anything with this cache, so they won't do that. So I would say this lock is definitely needed for whatever reason. And I don't want it to remain. I want people to know that our plugin has it's not an arbitrary plugin. It's a plugin that has been, thoughtful and thought through all the possible kind of races. The plugin needs to be abstract in the sense that, the locking mechanism is kind of framework, and for this plugin, it's a key. And that people can just play with it. It's just the validation part, right? They can use that logic for validation. So I think the validation API is kind of straightforward. They just need the pod, right? The pod object and the class name, that's okay. I personally think how you maintain the internal cache, it's up to you guys. I feel that is okay. You don't expose the detailed formulation about the cache. So you need some cache, right, about the usage. I think where you are going to hide that cache in your implementation, not expose it, right?
Yeah.
So I understand that's okay. Okay, so just out of view, in that cache, are you going to check if pods actually created? I'm just curious about your how you define your cache.
No, so basically we don't use cache. We just read every time from the API server to see how much quota left. So the API server maintain the admission controller and have all this information up to date. So this is why we lock it and we read it, and then we get this validate or not. Then we create the object immediately. So then unlock it. So next request comes in, because when this P pod get created successfully, admission controller in API server will already capture the quota. So next time come in, next request come in, already see the up-to-date quota. So the next one won't be get confused if there is anything.
I'm getting it. So you are saying that in your validation pass, if it, I understand. So you have a quota CRD in the API server.
Quota CRD, no CRD,
No,
kind of CRD.
Okay.
So
okay. So if the tenant say I only have a quota for one part of hit the sinker and the pass the validation. So how do you do the validation in the validation plugin, right?
So of course we have some. Of course, we have to configure that how much quota you have for this tenant. This is
let's say that is configured in the tenant CRD, right? Let's say that CRD only one part.
CRD or your config whatever.
So in the one part, then I'm assuming your validation plugin part, you will get the quota from that quota CRD. Say I have one part, then you check this part, and this part actually fits your quota, right?
Yeah, so there's three information. One is how much you have, then how much you used, and how much you want to use. So how much you want to use is from the pod itself. You how much this request need the quota needed. This is you get from the pod, from the request, how much you can check for the pod spec. And how much you have is already the configuration, there's no change. So only the thing that you need to get how much you have been used.
Yeah. How do you
how much you have been used? You get from API server that you can aggregate some of the namespace, whatever, in your tenants. And
okay, if there's one part that pass a check, but that has not been upgraded. So
what
we aggregate off resource quotas. So we're aggregating off of resource quotas in the supercluster, so not in the tenant control plane. And so basically what we're doing is in the synchro.
What I'm saying that you have a tenant, right? You have a quota, and you just admit it, right? I'm assuming you are going to release all the lock and having the next part come in, but the previous part has not been created in API server yet. So the used. It
is already. It is. When you do this one, this instruction part create.
Oh, you put this inside the lock?
Yeah, so this is why this is deferred. So you see, this deferred until this is this line was hit. So this was including there has to be. So this is why I said this atomic operation, two operations have to be together. I can do this one in my validation as well. I can put into my validation, but
I see. I don't see. I mean, theoretically, I know in practice may not. Theoretically, they may still have conflict. Does it? Because you are going to update the used in another controller in your CRD.
What?
I mean, this doesn't mean that this product creation finished. It doesn't mean that the usage has been upgraded in that CRD.
No, not CRD. This is no. Right? This is API server data. API server keep all the quotas. If you enable the API server admission control, like the quota management things, once the creation is a hit end, API server immediately update your quota. No matter
okay. You are not updating your CRD. So every time you do validation, you are going to read it. API server
quota. This is just one simple implementation. We were going to implement more cache later, but this is one simple operation that we can do that way. If we have a cache, we can do the same thing. Cache is more complicated because we have another option can do cache, and we haven't reached that. User can choose
I thought you were going to have a cache. Otherwise, this is kind of pretty expensive, right? Every part created, you need to scan all the namespace.
Actually, okay, it's not too bad, but because maintain cache is also a lot of kind of not cheap. We have something developed, but this is arguable. We can discuss later. If
think about it.
But no matter
this query cannot be used controller, cannot use informal cache. It has to go to the API server directly. Every time you check the quota usage, it has to go to API server directly. You cannot use any informal cache because you want to get you want to make sure you get a persistent value. So
yeah.
then you have a lot of pods. So every pod creation needs to go through API server to query everybody. I mean, I know, but think about the potential performance hit.
We will do more. Yeah, we can just, yeah, this is we can think, but I'd really like to have this two things become automatic, so that we were even we have a cache, even we do a cache, we still want to be this one to be executed. We don't want to track the pod and do a big database, see how much pod get eventually created or this thing. So we still want get whatever. If you are cache here, we still want to keep this in the same atomic kind of a operation that make sure that this pod is got created or not created. So we can decide its cache get update or not. So this is the thing that we always want to be in sync. We don't want to have these two instructions separate, and we end up with a pod tracking number and see if the pod, what's the state of the pod, and we remove from cache or add from cache. This is a very complicated. So even we have a cache, we still need this to be locked. Make sure we know it's created or not created. Then we.
I mean, you can have a come of different design anyway. So
no, this is
you can
okay.
do you can do kind of
yeah. What I'm saying
optimistic locking in the sense that you you just check.
Yeah, no
anyway,
matter what.
You just don't use
no matter,
the default.
Yeah, no matter if it's using our API server or we do a cache, I still want to be a kind of a consistent state at the end of this plugin that we know the pod got created. At least from API server standpoint, it's got reused, the quota being taken out from the total quota from the API server. The schedule or not is another thing. So this is what our thinking. We can implement cache later. This is the user's choice.
It's okay. I mean, this is details. You can choose to implement using cache or not. It doesn't matter. So validated plugin. So you're in. So. If you have plugin, you have to put create inside the lock. Yeah, that's probably only one thing that not very focused. So
no, if you don't think this is good,
no,
user can add this one in their.
So I'm just assuming in the end you have a plugin. So in the plugin code, you put the pod creation inside the lock. My whole point is that I don't know how to, or you need to have why do you do this? But once you explain this, is go to your implementation details, and which is not a formulation in any of the plugin design. This one probably
Yeah, I can do this one as well. If you don't like the format, I can do this one. Here, I put this line, duplicate this line into this plugin. User can do that also if they want, and just get the return. But this is more clean this way. So
you default, so everything is going to be.
Yeah, so this will be the plugin itself. The body of plugin is here, from here to here. And the user in this reconcile pod creation, you have this new line injected. These things injected into it.
Okay.
And there will be a flag.
Okay.
There will be flag.
I think it is maybe okay. So just lock everything. It's just implementation details. You can probably interesting. Okay. Yeah. Okay. So I'm just afraid. So the only concern is do we want to set any validation? So we don't want to set any rules for the validation part. Okay. Yeah, maybe a simple plugin is just something like this.
Okay. So let me take care of this your lifecycle stuff with the cluster 90. Then I'll give you another design in a few days.
Yeah, the tenant map. So I would hoping. When I see the design, I clearly know the life cycle. So I clearly know if we have any possible memory leak problem with this. So for now, I don't know, because you just put it, you describe me how do you do life cycle, but this is not clear in the plugin design.
Okay. Yeah, this is pretty safe because periodically I just go through all the tenants and take out all the.
Yeah, well, what I'm saying that unless you put that periodic stuff in your plugin, if you don't put that, it's not clear. If you put that in part of your plugin code, maybe okay.
Yeah, I can. Yeah, I can update
just one
then.
design.
Yeah.
Another design is just make sure you hooking this alternative tenant map is consistent with the tenant CR lifecycle.
Let me see if we can make it or not. But yeah, I will very likely to put this quota handling stuff in the periodic checking there. And it's quite
If you
safe
put that
there.
away, I mean, again, if you put that away, that periodic checking has to be part of the plugin.
Yeah, sure. This is yeah.
If you do that way, so well, it's possible. I mean,
yeah. Okay. I will give this update.
Just check if you can hook the tenant lifecycle. I don't see there's a. I probably need to go through it again, but I don't see there's a big.
Okay.
It's very difficult.
Okay. Okay. Got it. That's it for me. Our update document with this either hook up with the tenant lifecycle or the periodic function. I will show you, at least give you 2 options. Okay, that's it, Chris.
Awesome. Thank you.
Okay, thank you.
All right. Is there anything else we want to chat about? Otherwise, we can end. There's a new person just joined. If you would like to, oh, never mind, dropped off. All right, folks. What are your thoughts, Faye? You look like you're deep in thought.
Yeah. I was thinking, if you do, as you mentioned, if you don't have a cache, do you really need a lock?
I need a log because I have to rely on these 2 operations together. How can not just a reading? How can I get this two instruction?
I know. Yeah, lock is better. Lock is better.
Lock is unfortunate if we have a mechanism.
You still need a lock because you have 2 threads. Everybody read from the. You have a sound ring hertz. You eliminate 2 pods, but in the end there is only 1 left. Because Q thread can read the quota usage at the same time.
Yeah.
And everyone see there is 1 left, then they admit 2. You fail at the server side.
So if we had checks on the object that we were actually submitting against, so say for instance, in our instance where we have a virtual cluster quota, if we basically had an admission webhook on virtual cluster quotas in the supercluster, and you were constantly patching before you tried to create the pod, you would fail on patch on the second pod trying to update it. Basically, you'd get a conflict, and then you'd go into a retry loop, and then you'd get a failure the second time around, which would be the way that you do this without a log.
Yeah, you'd better fail it earlier, right? So in the syncer, you don't have to push too much unnecessary pods into the API server. If there is a race, it's going to fail anyway. So you fail earlier, that's definitely a problem. So I still think it should be okay with the pod and with the cache. So in other sense, if you want to implement a cache in the syncer for the quota usage, you definitely need a lock for sure.
Oh, because you're getting at that the cache could be out of sync with what the API server is. And if you're operating purely off of the API server, then it's going to fail.
Yeah, because you need to check anyway. So you need to check anyway. And the good thing have a cache, you don't need to you don't need to read the API server for every pod creation because you already cache all the quota usage in your cache.
But you still need to get the kind of a atomic operation.
So
Unless
like,
you want to
it
do
is
the
atomic.
speculation. Yeah. Unless you want to do
that cache is upgraded with pod creation.
right, because
You
the
probably
resource
have a
quota is
little
going to get
bit delay.
updated.
Yeah, so you probably have a little bit delay on pod creation. So that's another possible point, right?
I guess so. So what am I missing there that would make it so that what does that make? What does the lock do that makes it better? I guess that's what always has confused me about this whole setup is like, so if we were to not do it with a lock where you didn't have that in place,
and you will have a two thread, create two pods. So every thread read the API server, find that the quota is okay.
Mm-hmm.
Then they will admit the two pods, but only one can succeed because your quota can only support one.
No,
only
two will succeeded. Maybe two, but yeah. Sometimes
only if you could actually continue to update that object though. So like if you were constantly keeping a used state, for example, on a quota. So like if you think about the way that the resource quotas currently work inside of the API server, you could send 50 pods to 50 different instances of the API server, and some of those are going to fail based on quota. So like it's already worked out. It's already worked that out by using the cache itself. So or by using basically doing reconciliation at the admission lifecycle. So what would stop us from being able to do that same exact thing in this? So basically. Go ahead, Wei.
No, the problem is that there's no admission control on the API server side. So when you have a kind of virtually pretended quota, it's kind of virtual. It's not sync with API server. So when the two pod, as the Fei mentioned, go into it, and both of them think its quota is not reached, then they were all created. But at the end, both got created one, but the quota already exceeded the maximum. Because when they checked it, they see, oh, my quota is enough. And another guy will check, oh, my quota is still enough for fitting it. Then at end, then you have the problem to delete this, which one is created, exceeded the quota. Then you have to do the reverse work, which is more complicated.
So slight change on that. So, okay, so imagine if you basically had virtual cluster quotas like we have it defined in our current supercluster. You put, because it's a low risk thing and it's only mutated by the syncer, you put a validating admission webhook on that object specifically, not on pods or anything like that, but you put it just purely on the virtual cluster quota. And every single time, or actually mutating and validating, I guess, and every time you get a pod that's synced down and the resource quota object gets updated, you're also triggering an update across the virtual cluster quota because we're aggregating there, and then we're setting a used field in the virtual cluster quota. Tell me, you're shaking your head. Tell me what am I missing?
So you're not doing that way. I mean, that way, so there's no, so, okay, first thing is I think the lock is trying to avoid unnecessary pods. Basically, without a lock, the syndrome is that if you have a concurrent pod access, pod creation will fail. With the lock, they're trying to, I think what we were trying to do, instead of create one pod and let it fail, let's try not to create a pod at all. Just give you a failure from the syncer's point. That's number one. The number two is, as I asked way before, that you guys are not implementing like thing that you upgrade usage for them. You don't do that way. The thing is, I think Wei is going to scan all the API server for the normal namespace quota because only that quota is upgraded consistently with pod creation. If you rely on the controller to upgrade your tenant CRD's quota usage is out of sync, it's async process. You will have a race.
You're basically, yeah, I see. Okay, because you're saying that, yeah, so if every single time we're triggering off of resource quota updates, we're still a background process for updating the used field.
You cannot do that. Otherwise your check, the quota and the check is not guaranteed because you are going to always have a race, right? You will have an upgrade latency between these two. So
now, what if you did it off of the resource quotas though? So yeah, the admission lifecycle for resource quotas.
Work makes sense is because the pod creation we are automatically, not automatically, will be synchronously upgraded the namespace quota usage. One pod is created. So you are sure once the pod creation returns the quota usage is upgraded already in the API server.
Yeah.
Now, every time you do the quota check, you need to scan the API server to get all the namespace the usage. That is consistent with you. That's okay. I mean, from practice point of view, that's okay. The only thing I'm saying that may, I mean, performance may you hit some problem because actually you need to scan API server, yeah, all of them, and you cannot use any informal cache to cache the results because you are going to have a delay. So I'm okay with that. This sounds to be a simple solution for now. I mean, if performance is not really, if you really want to improve performance, you have to slightly change the mechanism you do the quota check. You probably have to maintain a cache and you don't track the usage at all. You can do something like that. You just assume you create a part, you occupy the. You just occupy it. So just don't track the usage at all. That's something. That's you can.
So
do.
this way, with the cache, when the pod got created successfully, then I upgrade the cache.
Yeah.
So then the next time the guy comes in and have the fresh, up-to-date cache.
So you don't have to track it. So every time you just use the aggregate paths compared with aggregate. I mean, the capacity is not going to be changed. It's going to be changed very infrequently.
Right.
And the usage in the sync knows all the usage. So just don't upgrade the used part. Don't upgrade it. So you don't need to worry about the which are left. Just do a total capacity check. Then that's also doable in the cache. Slightly different compared with the way that the API server does. And in this approach, you will avoid hit the API server, but you probably have a false negative in the sense that I have a part upgrade in the cache say it's going to be created, but in the end it's not created in the API server. Then the next part of mission may fail, which is really a false negative. Again, just trade-off between the false negative and the performance.
Gotcha.
Yeah, so the complication for the cache is that you also need to track the pod deletion. All these things you need to be tracking because so
again,
this
it's just complexity versus performance. Sometimes, I mean, you have to resolve the performance problem if you indeed you want to support large amount of. You don't want in every part creation in many tenants just directly hit API server. It's pretty. I mean, it's not trivial, as I said.
Yeah.
All right, thanks for that.
Yeah, it's okay. I mean, in the first place, making everything simple, that's maybe okay.
Interesting. Okay.
Yeah, I would say once you hit, let's say, hundreds of tenants, if everybody just try to create part in a burst way, your API server will have a lot of direct access. I mean, part creation has to be, but in Sync design, we were trying to avoid auto query. So every read operation coming from the cache. This is what we design in the Sync. So write go to API server. No, you have no other choice. Write has to go to API server, but read, we tried to read everything from the informal cache. But the quota stuff, you cannot read from informal cache. If you want to do the strict mission control.
Interesting. Cool.
Yeah, it's very helpful.
Yeah. Thanks for going through all of this, both of you.
Okay.
All right, y'all. Anything else you want to talk about?
Yeah, I don't have. So yeah, I like to see your upgrade version. I think it's close to finalization. So once you upgrade the tenant map lifecycle stuff, yeah, I'm asking our guys. There's one guy left a comment, which is a guy from our team. So
yeah,
he was always
I answered it.
Yeah, he was also interested if you can also put a CRD in the design.
It's very simple actually.
Yeah, given CRD is we are less likely to get a consensus on the CRD design, and people most likely.
Yeah, CRD is just for the configuration, not for the tracking.
Yeah,
for the cache.
I think it's okay. I think okay. I mean, design with the sample code should be straightforward. But I still see some.
Yeah, I will get some more data. I'm going to do more testing and see how much performance we hate.
Yeah, performance. I don't worry. I mean, it's small scale.
Actually,
unless you do really big scale testing. So if you guys really want to
do the big scale, yeah.
We have scale, actually. I don't worry about that at all. I mean, any test in the POC stuff, you don't hit it.
Yeah, but I have the cache design in-house as well. Exact same cache, and we have in-house, so we can compare a little bit.
You can think about more. I mean, this kind of thing is not very easy in the sense that if you do it really efficient, it's not very easy. I mean, I would say the most easiest way is change the best server. That's the most efficient way to do that.
Yeah, it's a much
Think about
easier.
it.
I
Think-
go through the
yeah.
cache first. I go through the cache first with another folks, and we end up with so many corner cases, and still.
Yeah, you can think about the design, right? Every time you have something that you try to do the mission, that mission has to be done in a synchronous way, like the mission webhook. you put a potential parallel, or the mission webhook is even worse, right? I mean, it doesn't allow parallel product creation. So
yeah, if we really wanted to do this, and we need to do like a compiled in admission control at the supercluster level that's doing all of these checks. It's like the only way that we could do this fully synchronously and not have any of this stuff.
Yes, yeah. This is a kind of, I mean, the design is, I want to say it's messed up. It's kind of, you have quite a few places doing admission check, right? Some scheduler has a part of the admission check that is based on cache and for node capacity. And you have another quotas admin check that is building in the API server that is protected by lock, for sure. So what is the extension point? So you want to extend the quota check with the CRD. That's, I would say, is pretty, it's tricky.
Yeah, for sure. Cool. All right, folks. I'm going to end the recording for us.
Okay.